Now, if you were paying attention in that last video, you saw that when we had something that was right here, 10 meters long, it had one significant figure. When it was 10.0 meters long, it had three significant figures. So is there a way to show the number 10 with two sig figs to show that you're guessing on the ones place when you're making your measurement? So if the number 10 just has one sig fig and 10.0 has three sig figs, how do you get in between 10 and 10.0? Well, you can write 10 with a decimal point. Anytime you see a decimal point at the end of a number, it's telling you to count all of the digits in front of that decimal point as being significant. So it's saying to count both the 1 and the 0. But you could maybe see how some of my students in the past have gotten a little sneaky with that. And they're like, well, I'm not really sure if my number's supposed to have a decimal point at the end of it or not. So I'll just put a tiny little dot and we'll let Mrs. Carlson decide if that's a decimal place or not. So it's totally legal if you write it that way. Just make sure that your decimal point's obvious. Another option is to write it in scientific notation. 1.0 times 10 to the first. We know that 1 counts, and then this 0 is a right 0. It's to the right of the decimal point. It's to the right of the number 1. Therefore, it's a little more obvious. What if you wanted to show the measurement 200 centimeters with just 2 sig figs? Well, if you just wrote 200, then the 2 would count and those zeros would not, because there's no sandwich, they're not right. So this guy only has one sig fig. So then if you're thinking, oh, I'll just do that little trick where I put the decimal point at the end, well, then the 2, the 0, and the 0 would all count, and so that guy would have 3 sig figs, and that's too many. So how do you get in between 200 and 200 point? What do you write now? Well, you can't. You can't split those hairs. There's nothing you can do that's in between those two. So this is one of those times where you have to put your answer in scientific notation. 2.0 times 10 to the second. So the 2.0, the 2 counts. This is a right 0. In your head, when you see times 10 to the second, you're like, oh, move it over a couple times. So you're talking about the number 200. But it would be impossible to write this measurement as a standard format number. It's rare, but it does happen. Now, some numbers are considered to have infinite sig figs. These are if your objects are being counted or if you have conversion factors. So an example of a counted number, there are 26 AP chemistry students in a classroom. Someone can walk in and count how many of you there are. They don't need a measuring tool to figure out how many students we have. They count 1, 2, 3, 4. They don't need a ruler, a graduated cylinder, a balance to get the mass, right? It's just counting. If a 5-year-old can do it, it's a counted number, right? If you hand a 5-year-old a ruler, that's a measurement, and that they would be a little bit confused by, right? So counted versus measured numbers. Counted, it's not 25.999 AP chemistry students, and it's not 26.0001 of you. It's 26 on the nose. We just don't write 26.00000000 until our hand falls off because, well, that would be absurd, right? Also, there are some numbers that are conversion factors that are exact. So if I were to say there are 60 seconds in a minute, Well, if I just said 60 seconds, the 6 would count, the 0 would not because it's not in a sandwich. It doesn't follow the right rule. So just the number 60 out there on its own, we would say has one sig fig. But when we make it a conversion factor, 60 seconds equals 1 minute, there's exactly 60 seconds in a minute. Not a little bit more, not a little bit less. It's 60 on the nose. We just don't write 60.000000 with infinite right zeros. So if we were to look below, which of these are considered counted numbers, things that would have infinite sig figs? You can count how many dogs there are in a room. You don't need a ruler, you don't need a balance, you don't need a graduated cylinder. You're counting, not measuring. So it's 37 on the nose, 37 dogs, not a little more, not a little less, not a measurement, you're counting. You could count out cans of Sprite. There are exactly 12 inches in a foot, not a little more, not a little less. But these other ones here, a dog's mass is 24 kilograms. We'd need a balance. We'd need a scale, a measuring tool. That's a measurement, not counted. We would need a ruler to measure the dog's height. Measurement. Estimated digits. That 9 is a guessed number. Right? If you wanted to pour out 125 milliliters worth of Sprite, you'd need a graduated cylinder, a measuring tool. So that's how you can tell the difference between infinite sig fig values and ones that have a limit to that number.